Okay, this is lesson 6.9. This is applications in trigonometry. In this lesson, what we're going to do is I'm going to do 2 examples of finding lengths and 2 examples of finding sides, or angles, sorry, and I'm going to leave 1 example for you. I'm going to leave you the examples that have a diagram. 2 of the examples are missing a diagram. They should have been printed, so we're going to draw them together, and then we're going to do those questions as well. So we'll do examples 1 and 2 in both lessons, and you will be left with example 3 to try, and example 6 on the next page to try. All right, let's give it a shot with example 1. Find the length of AB to the nearest length of a centimeter, and we have our picture. We're finding a length, remember, so let's label our triangle. We're given the angle 37, across from the angle is O, across from the 90 is H, and that leaves us with A, the side we don't know. If we highlight the one we want to find O, and we know H, SOHCAHTOA will tell us, SOHCAHTOA will tell us which one to use. We know O and H, so we're going to use SO. The question kind of ruined it. It said sine ratio right there at the beginning, so we're going to use sine. So here we go. Sine of an angle is equal to O over H. And now we can fill in what we know. Our angle is 37, so we got sine 37 equals O is our unknown x over H is our 11. All right, and our unknown side is on the top, so we can use the Drake move here, number from the bottom, and put it there. We end up with 11 sine 37 equals x. So now we can just use our calculator to figure out what x is. X is 11 sine 37. And we get 6.6. It says 1 decimal place, so there we go, 6.6, and we're in centimeters. So if you punched in 11 sine 37, didn't get 6.6, reset your calculator or put it in degree mode because you're probably in the wrong mode. All right, let's try example 2. Example 2 says cosine ratio, so we're probably going to use cosine. I would never ask you to draw the diagram from a description as poor as this one because it's very unclear as to what's going on here. But it says Jamie's kite string is 35 meters long and it makes an angle of 50 degrees. That means with the ground. Let x be the horizontal distance in meters to the kite. What is the horizontal distance between the kite and Jamie? So what's this look like? Well, let's draw Jamie. Jamie's got a kite string. It's flying a kite. The kite string is 35 meters in length. We have 2 distances on this kite. We have a vertical distance, so how far it is above the ground, and we have a horizontal distance. And where those meet, they meet at a right angle. We're told that the angle we make at Jamie is 50 degrees, and we want to know the horizontal distance, which would be this side. So let's label our triangle. Across from the angle we know, 50 would be opposite. Across from the 90 would be our hypotenuse. And the side remaining, the one touching the angle and the 90, would be our adjacent. The side we want to know is our adjacent side, and the side we know is our hypotenuse. And SOHCAHTOA would tell us what ratio we're going to use. We know we want A, we have H, A and H is in Ka, so we're going to use cosine. So let's write our equation. Cosine angle equals A over H. All right, let's fill in what we know. We know the angle is 50, so cos 50 equals A is our unknown x, and H is 35. And nice, we've got x on top, so we can just bring the 35 up in front of the cos and multiply. 35 cos 50 will tell us what x is. Cos 50, we get 22.5. And we're working in meters. So this one is an actual word problem. So it deserves a word answer. So we can say, therefore, the horizontal distance is 22.5 meters. All right, there's our two examples for finding lengths. There's one left where you're going to use tan, and it's about an escalator. So you can pause the video and give that one a shot now and check your answer, or you can wait till the end of the lesson and come back and try that one on your own. We're going to move on to some angles. A storm caused a 13.5 meter hydro pole to lean over. The top of the pole is now 11.8 meters above the ground. Find the measure of the angle between the pole and the ground. Here's the pole, there's the ground. We want that angle. So we're going to find an angle. We're going to first label our triangle with O, A, and H. Across from our angle would be our O. Across from our 90, 90's here, would be our H. And the other side would be our A. So the sides we know in this example are H and O. SOHCAHTOA will tell us which equation we're going to use. We got O and H. The one with the O and H in it is SO. So we're going to use our sine equation. Sine angle equals O over H. And now we can fill in what we know. We don't know the angle. O is 11.8, H is 13.5. All right, and in this example, we'll do the division and get the decimal. So we got 11.8 divided by 13.5. We get, 0.8740. And the 740 is repeating. So if we round, we get 0.8741. And we rounded, so I'm going to put the dot over the equal sign. And now, if we want our angle, we just do sine inverse of that decimal. So remember, if you're going to do the division and get the decimal, I want 4 decimal places to make sure we get the answer right. Now we can find the angle. So we got second sine, 0.8741. And we get 60.9, nearest degree, 61 degrees. So this is a word question. We'll give it a word answer. Find the measure of the angle between the pole and the ground. Therefore, the angle between the pole and the ground is 61 degrees. All right, last example. A tower is supported by a wire. The wire is attached to the tower at a height of 19 meters and to the ground 8.1 meters from the base of the tower. Find the measure of the angle formed by the wire at the ground. All right, so we go draw a tower. I'm not really an artist. Let's just draw a line. We'll put this at the top. There's my tower. And we got the ground. And there's a wire from the tower to the ground. So there's our triangle. It's a right angle triangle because we got a vertical tower and a horizontal ground. We'll call this our wire. The wire is attached 19 meters up, so we've got 19 meters, and 8.1 from the base. And there's our diagram. And we want this angle, the angle at the ground. So let's label our triangle. Across from the angle is always O, across from the 90 is always H, and the side between the angle and the right angle is always RA. So what do we know? Well, we know the opposite side is 19, the adjacent side is 8.1. SOHCAHTOA will tell us which ratio to use. SOHCAHTOA. O and A is in TOA, so this is a tan question. So we write our tan equation. Tan angle equals O over A. Then we fill in what we know. O is 19, A is 8.1. Tan angle. In this example, we won't get the decimal. We'll go right to the inverse. So our angle is tan inverse of 19 divided by 8.1. And we'll do that in our calculator. Second tan, 19 divided by 8.1 equals 66.9. Round to the nearest decimal, we'll call that 67. Sorry, round to the nearest degree, not decimal. 67 degrees. So now we can say, therefore, the angle formed by the wire and the ground is 67 degrees. All right, that's it for example 5. You can try example 6 on your own. It's about a wheelchair ramp, and we're finding an angle. That's it for lesson 6.9. Be sure to check your answers to those 2 examples that you try on your own on the class website. And thanks for watching. And this is the end of Unit 6. So I'll see you for our last unit, Unit 7, where we look at measurement. Thanks for watching.